and say good afternoon, everybody. I'm Tommy White, one of the developers of the MasterSeries, and today we're looking at masonry design. We're looking at masonry design to Eurocode 6, and we are joined today by people from all around the world. I know that people are coming in as far afield as South Africa, Singapore, Malaysia, and also as far west as America and Canada. I'd like to say welcome to those who are staying up late to see us, and good morning to those who are joining us very early in the morning from the Americas. So I'd just like to run through basically what the PowerPad is all about. So it is for designing masonry walls and columns. We can do stiffened and unstiffened single and cavity leaf walls, and we can alter and vary the support conditions, including partial fixing when you've got a arrangement where you're not 100% fixed but not pinned. And we can apply line loads to the free edges, so we can actually have free edges, and we also do load bearing walls as well as your normal infill laterally loaded panels. Non-critical panels, particularly to the BS code, where you can reduce your load factors, and we can also apply shear loads to the walls and design them as shear walls. Piers can be done in tension or compression, so that we can look at both directions and make sure that we're not missing something. And we also handle, for those of you who have the PowerPad version, we do not do bed reinforcement. The bed reinforcement is in the full version of the MasterKey Masonry Design, and likewise openings, either one or two openings, is in the full version. Now just close this and stop this for a second. Press escape, and we'll just start on the main MasterSeries. So this is the front screen of the MasterSeries, and I would stress to everybody that if you don't have the masonry and are interested, we do have a 30-day trial copy that you can request. Just come onto the website and request that very simply. That is accessed if you come to our website, into the home page. You just come along to Masonry Design, into Masonry Design, and you will find, and I'm using a low resolution here today, request a free trial, where it will ask you your details. And yes, I'm interested in this case, retaining walls. It shouldn't be retaining walls, it's masonry walls. I think I went into the wrong one there. And we will get you a free trial on the software. So this is the main front screen of the MasterSeries. We can see that we're using the 2014-09 version, and it's a 64-bit. Won't make much difference to the masonry design, but for other programs most certainly. And it's licensed to ourselves. So let's just go into masonry without any further talking, just straight in to masonry design. And I will go and load up this demo file that I was playing with this morning. So the basics of the program are very simple. It is one of the most simple programs that we have to use. It's still very powerful, but it's simple. Obviously we're seeing our wall, and we're seeing that we've got a lateral load of 0.75 kilonewtons per meter squared. It's a single leaf of 140 thick, and it's got the standard symbol for fixed edge from the code of a cross hatch on the base and a single hatching on the other three sides, indicating that we are in fact in simply supported. So fixed base, simply supported edges. The screen's blue, and that is significant. What that's telling me is that the wall is failing. Why is it failing? It is failing on moment capacity. So we can see that we are 4% overstressed, and we will take action to solve that in a minute. But let's look at some of the simple data we have. The wall data. So we mentioned that it was pinned, pinned, pinned. And this is very simple. All you need to do is just click on an edge to make it fully fixed. Click on it again, and that's now 50% fixed, not pinned, not fixed, but somewhere in between. If you have a beam support, you might even consider putting in a minus 50%, so it's less than pinned. So it's going to give a wee bit of give, but not totally. And you can return back again, and that's a free edge, so it's unsupported altogether. Now when we have a free edge, we are able then to apply a line load to that laterally if we want to simulate a load coming from somewhere else, if we were splitting our wall up into different location segments. So rather than change the fixity of my wall, I could come along and say my single leaf wall will work at 190 thick, or I could go and look at the second wall data tab, and here we have our material strengths. We have our concrete blocks, and of course we have our clay bricks, concrete blocks, silica bricks, autoclave aerated concrete, stone, and natural stone. So we're into concrete blocks. Group 1, which means that we don't really have any holes in the blocks, any significant holes over 25%. And we're going to go for category 2, execution class 2, the standard unsupervised construction. And that's not working, as we said earlier. What we can do is we can change our strength, and if we go up to 17 Newton blocks, it will work. Or we can turn around and say, well, really, the blocks at least will be manufactured under QA controls, so we'll go for category 1. And that hasn't really helped this. So if we go for category 1 construction, then the pair together will say yes. If we have a clerk of works or resident engineer and we have good supervision of our construction, then we will see that this wall will work at 140 wide. So what we're seeing is that throughout the program we have a choice. We can either make it thicker, we can make it stronger. So the choice is always yours. Now let's look at our next wall and see what we can do. So moving forward and up, we're now into a cavity wall. The same wall, 0.75 kilonewtons per meter squared, with a 102 brick external wall and 100 internal leaf. Again, fixed, pinned, pinned, pinned. If I just made that, come back to here and make that pinned on the base, we now see that it's not working. So again, we can see how sensitive the wall is to the changes. We now have the data for the inner and the outer leaves, concrete blocks, group 1, category 2, class 2. So let's go for class 1. So our concrete blocks are class 1 and it's now working. What you'll also notice is that we have facilities here for applying additional load onto the wall. By default, if we put a density in, it will be enhancing the strength, so the FXK, and you then have your gravity enhancement to give you an enhanced FXK1 of 0.33. So a 10% improvement in the strength, in the flexural strength parallel, which is useful. Naturally, if I started to put in some additional loading of say 10, we will see that we also get some additional strength coming out of those loads as well. I make this into 10 and we're now getting a wee bit of improvement. There are 4 inputs here for loading, and the reason for that is very, very simple. These two are concentric from above. So self-weight of an upper leaf, or the loading on a floor from above, the GK and the QK, to quote the BS terminologies, are concentric from above. For loading at this level, we can then put them in eccentric by the default 20 mil or larger value if you feel that's more appropriate. Naturally, we also have the mortar designations, but they don't really give you much variation from the M4 and M6 mortar designations. Now, I just noticed back when I was looking at my questions that came in before the webinar that somebody was asking how do you actually create a cavity wall? Well, if we went back to the first wall, it's very simple. All you do is you tell it that you want it to be cavity, or you tell it that you want to have a stiffened wall. Stiffened cavity wall? Yep, why not? And turn it off and turn it off. So we can turn on and off the options very, very easy up here. And if we look at these options, we can see that we also have the fixities, so we're actually fixed on all 4 sides, or we can go for a standalone or vertically spanning and back in again, and then we will see later on our openings in the walls. So let's move across using our examples. So this was the 3rd example, and this example we have the axial load from above coming eccentric, so it's from this level. And then we have a panel that has not got any top support. For whatever reason, we are not relying on top support, and you've seen how easy that is to remove the supports. The other thing to worth of note is that it is technically possible to have different fixities on each leaf, and we can ask it to say, well, right, that is the inner leaf and that's the outer leaf. We're going to have expansion joints here, but on the inner leaf we're going to be up against something and we're going to be shot fixed onto it with no and we're going to be fully enhanced. So it's giving us a plus 50 because it's taking the average of the two. Now in reality, most of the codes, certainly the British code, tells you that you don't have to do this, because if one leaf is continuous, you just assume both leaves are continuous. So I'll put that back to pinned and I'll turn that off for this example, but for those who want to do it, it is available. Now moving forward again, we're now into our freestanding walls. A single leaf freestanding 2 meter high wall with a 0.75 kilonewton per meter square wind loading on it is going to need to be 440 thick. If I play around with that and go down to 325, it won't work, and up to 440. Naturally, we have a wee bit of scope on our blocks, but those are really for axial rather than flexural strength, so they're not really going to benefit us here. And if we decided we didn't want to have a 440 wall, the alternative is to think about piers. And one of the nice things about our system when we're doing piers is that you can play off one against the other. What I mean by that is very simple. If you say, right, we want a 215 wall and we want piers. Well, the piers at the minute are 1800 centers. Could I work them at 2 meters, 2.4? No, at 2.4 meters, this 400 by 650 wouldn't work. If we didn't want 650, but we wanted 500 or 440, we would see that we would then need to decrease the pitches of the piers to be a wee bit unrealistic. So let's go back out to 550 and we'll see at 550 we could get away with 1300. So I think in this case it would be more realistic to take it on out to the 2.2, and we'll find that that is a more economical construction in this case. Naturally, you also have the recourse to thin the pier, rather thin the web of the pier, and we would be down again to 1500 centres with that 325 pier. I would be fair to see something around about the 18 to 2 meters, so I am going to be saying a 440 pier. That is the widest we can go. So on a long run we can see how far we can get these piers apart. So pier design is again very simple, and of course we do have this option to say whether or not the pier is in compression or in tension. So at the minute we're assuming, I would have thought pier in compression, but we can switch it around and check that it works for both. So we really should confirm that it works for both arrangements and then design for the least. So in fact, pier in tension is the one that's least sensitive. So if this was not a wind case, but you were constructing this to support some sort of lateral fill, then we first of all wouldn't be using the wind load, but we could be using a triangular load. That's not a horizontal line load, that's a triangular load onto the wall, sort of as if you had grain or gravel up against this wall. And obviously with the wall rotated the right direction, we could actually make this so the piers in compression, this side in tension, we could actually reduce this. If we had, say, a 5 kilonewton, say 4 kilonewton load, we're nearly there on our loading, and we can ask it to be non-critical and reduce things. But obviously to the Eurocode, I don't believe that that clause actually works. So if we have a maximum of 4 kilonewtons at the base, then we would need to have our walls possibly just that wee bit closer at 2 meters apart. So we can do the wind loading, we can also do the triangular loading. So there we have the more visually correct description of our wall load. Now, the next stage we will look at is reinforcement. So what I'm looking here is to say, could we take this wall, could we make it thinner than 190? 140, yes. 100, no. So let's have a look. And in fact, I've already turned the reinforcement on. If I go back to my wall data, I will see that 140 was not working. The 190 was working without reinforcement. The 140 will not work without either strengthening the wall somehow, or in this case adding in 3mm reinforcement at 110 spacing every 225 vertically, and that will make that wall work. So quite an economic construction, and keeps our architects a lot happier. So the other wall we're going to look at for bed reinforcement was a standard cavity wall. If we look at our reinforcement, we'll see there's none applied. So first of all, with our 25% overstressing, we'll put some inner reinforcement, 3s at 60 centers, now 60 apart because we're only in a 100 thick wall. So that gives us 20 cover front and back, inside and outside. So that's not enough. We could say we would get away with more reinforcement, and it's not going to allow me. So I'm going to stay with the 3mm and put some bed reinforcement on the outer leaf. So inner and outer leaves, same reinforcement, so they don't get it wrong. And that wall now works without having to go up and put in a thicker inner leaf. So if I went to the wall without the bed reinforcement, we can see how much thicker it needs to be. So a 40% increase in that wall, 20% increase in the overall, and I'm quite sure that the bed reinforcement probably works out as a more economic solution in this example. Remember, folks, that if you are interested in trying the program, just go onto our website and request that 30-day trial. It's absolutely free, and you will be using the exact same system that I have here. Now, before we move on to the last area of the program, I want to just remind you that this program has a history, and it was working with the BS codes originally. So the BS 5628, and we can see the 5628, we were working with a 89.7 moment capacity. If we move on to the BS or the Eurocode, we're actually at a 95.7, so we are at a slightly higher capacity, utilization. As well as designing to the Eurocode, we actually are able to design to the different Eurocodes. So if you use a different set of load factors, a different set of parameters, you can actually go in and create your own set of defaults, your national application document values, your appendix values. We give you the default for the Euro, what we call the Euro norm, and we also give you the British one. And you're able just to take those and copy them and edit them very simply in the front area of this program to change to a different locale. So you're able to design for your country's conditions with ease and with confidence. The last type of masonry panel is the masonry panel with openings. The same panel again. Let's keep this simple, not change many things at once. And we have asked for an opening. So we just click on the opening button, very, very simple. And we have three primary methods. Main panel spanning horizontally, so we have a beam spanning across here, a beam spanning across here, and then this little panel spans vertically. So obviously these two beams are going to be loaded on the edge, and it's going to be crucified because it's quite a large span. If we attempt to span vertically, then we have this span working nearly, these working, and we have this one not working at all. We can, in the vertical direction, also ask to take account of the fact that it's not free the whole way along, but we have this edge component, so we're taking an overlapping approach, and that does get us down a wee bit. But one of the best methods we find for openings that aren't enormous is the reduced fixity method, and that takes this portion of the restraint and removes it at the supports, and it takes this projection and removes it, and this projection as it moves it. So we're into 850 plus 650, which is in my head 1500, so it's a 3-meter high wall. Yeah, so you can see simply we've taken half of it out here, so we're at minus 50% from 0, which is pin, to less than pin, and that is as decreed in the Concrete Masonry Designer's Manual, and works very, very well for small openings. Now we do check the size of the opening, because if I went and I made this opening 2.5, it would then refuse to do the reduced fixity method because the opening is too big. And if I went obviously down to 0.5, I would need then to push it back to the reduced fixity. But we can do not just one but two openings, and we also don't have to have these openings symmetrical, which is great. In this case, with the two openings, we're down to the 50% reduction on the verticals, but we're up to like a 60% reduction on the horizontal edges. So we do have a problem if we want to introduce two openings. And the best thing to do at this point in time would certainly be to come along and add some internal bed reinforcement. And we now have this opening panel working perfectly. So that, ladies and gentlemen, is a quick tour through the masonry panel design program. I say panel design, but we also are able to do columns. And this isn't two leaves, this is the one leaf just detailed in both directions. So it's a single leaf at the minute column, which is 3.5 meters high, and it is taking quite a lot of vertical loading, 20 plus 14 concentric loading and 6 and 7 eccentric loading. Eccentrically loaded quite significantly in one of the axes, the y-axis, and quite small in the x-axis. We can see it works if we have units of 22.5. Remember, I said that when we come to axial loads, the unit strength is very important. When it's flexural load, once you get above about 10 newtons per millimeter square, then you get no more real additional strength in flexure. So we can see that by putting in the 25 newton blocks, we have a solution. Now, if we can't get 25 newton blocks, the only solution is to make this column bigger. So a 325 in that direction, or a 325 in this direction. Now we could try and argue for a special cut on the bricks to make it only 300. That would work. Or we could ask for 250 square, which isn't going to be very, very smart to manufacture, which doesn't work. But to me, I will go for 325 by 250 blocks. So that is your program. Very simple to use. It is totally standalone from the rest of the Master Series. You can use this program without any other packages in this Master Series. If you're a PowerPad user, as I said earlier, the only thing you don't get are the openings and the reinforcement. Those buttons will be turned off. If you have the full version, you will have full access to everything else. So, ladies and gentlemen, that really leaves me just to say a thank you for coming today. And what are the benefits of using this MasterKey Masonry Design? Well, as you have seen, it's powerful and fast, and it is very user friendly. It uses the exact same interface as two of our other programs for retaining walls and composite beams. It designs to the BS and the Eurocode, and in fact historically it also designs to the Irish 325 code on masonry. It's very comprehensive. It's not a little tool where you say, oh, I can't make it work that way, we have to go back and start again and start inputting everything. No, you can just change your configurations on the fly and say, well, actually no, I don't want it to be vertically spanning, I'm going to have to take those side walls and see how it works. Or, oh, I need to put reinforcement in. So by giving you this rapid design turnaround, you're going to be saving yourself time, which is going to be saving yourself money, and you're going to be very economical in your design, which gives you an edge and keeps your clients happy and your contractors, that you're not over specifying the size of the walls. So just to finish off, I'd like to thank you all for coming along today, and remember, if you want to try the software for 30 days, just go onto the website, log in and request a 30-day trial. And if you have any questions, just email myself, Tommy at masterseries.co.uk, or give me a call on 028 9036 5950. So requesting a free trial. In we come, and this is a random splash. I'm going to go to Masonry, Masonry Design, scroll down and request your free trial, and then just fill in my details, and away I go. Very simple. So ladies and gentlemen, I would just like to say thank you very, very much for attending today, and I hope you have a good day. All the best now. Goodbye.